Hello everyone, welcome to Simply EDU, and in this video I'm going to be making the definitive ACT math guide. Throughout the course of this video I'm going to be explaining all the math that you need to know for the ACT math section, and so after watching this you should be able to ace the ACT math section, of course with some practice. Here on this slide I have the 5 different subjects that I'm going into, as well as all the different subtopics. And I know it looks overwhelming, but trust me, it's not a lot. You'll be able to understand it and hopefully be successful. Now, to start off, I have some general strategies, and most of these are some things that I already mentioned in my overall general strategies ACT video, but there's also some other things in here. Now, to start off, the first main tip is to take Algebra 2. Now, for the ACT, actually you should really go up to pre-cal first, but the concepts that are needed in pre-cal that you don't learn in other math courses are things like vectors and trig. And the thing is, as you go more and more advanced in the math concepts, the questions start to get less and less complicated. And so that's why I don't think you need to take pre-cal, although I guess it would be helpful. But I do think that you should still take up to Algebra 2, because without taking that, you're almost the whole test is just Algebra 2 concepts. So it's really helpful that you take that because you gain a lot of important skills. Next thing is the thing that I addressed in one of my previous videos, is testing order. You can go in either normal order or reverse order. And what I mean by this is that it's 60 questions in 60 minutes, right? And as you go from 1 to 60, they get harder and more advanced in concept, right? So you might start off with some Algebra 1 and end off with pre-cal or stats. And so that's why there's this question of if you should go normal or reverse. What I think is, if you don't know all the math, then you should go in normal order, because that way you can answer all the questions that you do know. But if you do know all the math, then I think you should go in reverse order, because you can knock out all the hard questions right away, and then you'll be able to go through all the more easy questions much quicker near the end. After that, another main tip is to use your calculator. Now, I personally use the TI-84 plus CE, but really you just need any graphing calculator and you should be good to go. But the reason I'm writing this tip down is because if you can just there's so many different functions that the calculator can do for you. There's a lot of stats questions that just by typing things into your calculator, you can instantly get the answer without really having to do any math on your own. And so using your calculator helps you to save a lot of time and answer questions more effectively. Finally is to plug in the answer. And this really works for things like systems of equations, but there's a lot of applications. Sometimes there's situations where if you really were not plugging in, you'd spend a lot of time just working it out trying to find the solution. But if you use the strategy of plugging in the answer, plugging in the different answer choices back into the question they gave you, you can often get the answer a lot faster. So, to start off, we have algebra topics. And the first thing is quadratics. Now, I think most of us here, as long as you've taken Algebra 1 and Algebra 2, you should know this, but I'm still going to go into it. A quadratic equation is in the form ax squared plus bx plus c. And the quadratic formula here is used to find the x value at the x-intercepts. In other words, whenever the formula ax squared plus bx plus c is equal to 0, what is the x value that makes that true? And now the vertex of the quadratic is found at the x value negative b over 2a. Now the vertex itself the quadratic forms a parabolic shape, kind of like this U shape here. The vertex is that point there that it switches from going increasing to decreasing, or decreasing to increasing. So the x value is negative b over 2a, and then the y value can be found by plugging in the x value back into the equation. Next up is exponentials and logs. Now here in this picture I have the conversion between exponential and logarithmic form. So let's focus on exponentials first. So this says that y is equal to b to the x, and b is just a constant. So let's say b is 2. Then when x is 1, y is 2. When x is 2, y is 4. When x is 3, y is 8. And so on and so forth. And so generally you're going to see the exponential form whenever you have a question talking about bacterial growth or population growth. Because bacteria, the population grows when you have one bacteria, it's going to split into 2, right? And then each of those are going to split into 2 more. And they're going to keep on splitting and splitting and splitting, and that's how the population is going to grow. So in other words, it's not just it's going to grow for example, over 1 hour it's going to grow 2 bacteria, and then 2 more each hour. It's not like a set rate. Instead, it's going to be based off the amount that you already have. Now, logarithmic form, on the other hand, is really just the opposite of exponential. Now, in this picture, it says that x is equal to log b of y, but usually when you're in function form, it's actually going to be the other way around. So y is going to be log b of x. And now, there's not really as many applications of this as there are for exponentials, So just make sure you understand the conversion between these two, and you should be able to answer questions pretty easily. One important thing to note though is that whenever b is 10, it's called standard log. So sometimes they might just write like log of y with no constant there. And that means that the b value is 10. Other times they might write ln. ln just means that the b value is e. And e is this number 2.718 whatever. But you don't need to actually memorize that, because in your calculator actually the constant e is already there. So for mine, right under where it has the caret symbol on the division symbol, if I hit second division symbol, it has the e value right there. And also I have the ln button over there, and I even have the exponential e to the x also on the calculator. So that's why it's important to use your calculator, because it helps you get all these questions answered. Finally is the systems of equations. So this is what I was talking about earlier with just plugging in the answer. For example, when you look at this question, right, I could just manually do the question, and honestly I'd still get the answer relatively quickly. But I also could go one by one through the answer choices. So for example, if I was going to plug in a is 2 onto this equation, what I would notice is that that's going to not make these two equations equivalent to each other. That's actually going to yield no solution. However, if I plug in b of 6 as the a value, then I would get an answer, and that would give us an infinite number of solutions. Next up is geometry. Now, I know that this is a lot of people's least favorite topics, but fortunately they also don't ask you too many hard questions, right? Like, don't worry, you don't need to know what the orthocenter is for the ACT. So, main things that you're going to need to know are the triangle properties, which is that the sum of the angles is 180 degrees, and then some basic trig, right? So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And then other things is the 30, 60, 90 triangle and the 45, 45, 90 triangle. So in the top right here, I have a 30, 60, 90 triangle, where we could say this is a 30-degree angle, this is the 60-degree angle, and this is the 90-degree angle. And so what's interesting is that in these triangles, there's a special ratio between the sides. For the side that's opposite the 30-degree angle, let's say it's equal to a, right? Then the hypotenuse is going to be 2a, and the side opposite the 60-degree angle is going to be a times the square root of 3. And you can check this by plugging it into the Pythagorean equation. Next up is the 45, 45, 90 triangle. And of course, because it's an isosceles triangle, these two sides are going to be equivalent. And so if we're saying that this side here is a, then this is also going to be a, and the hypotenuse is going to be a root 2. Next up are some circle properties. Now, I know this diagram looks really weird, but I promise it's not that complicated. So first we have the two formulas that I think we all know, right? The area is pi r squared, circumference is 2 pi r, or pi times the diameter. Now here I have written that the radius is always equal. And I know that we all know this, but the reason I'm saying this is that, let's look at this diagram here. You see this red side and this red side of the triangle. Both of these are radii of the circle, and as a result, both of them are equivalent angles. Thus, this is an isosceles triangle. And so for whatever the question is asking, realizing that will make sure that you can solve the question. Also, we have the diameter, hypotenuse, and vertex on the circumference equals a 90-degree angle. What I mean is, whenever you have a triangle right here in the circle, where the hypotenuse of the triangle is the diameter of the circle, and then its other corner point is going to be on the circumference, the angle that's made from that vertex point is going to be a 90-degree angle. And so this also is a property that you're going to need to know for a lot of other questions. Next up are some general graphing topics, and really the main thing that you got to know is all the parent functions, and also the midpoint and the distance formula. So the midpoint formula, it looks complicated, but it's pretty intuitive. So if I have, let's say I start off at 0, 0, and then the end of my line is at 4, 8. The midpoint is going to be at the middle of the two x values, so 0 and 4, the middle is 2, and then the middle of the two y values, so 0 and 8, the middle is 4. Thus, my midpoint is going to be at 2, 4. Now, the distance formula also looks complicated, but really this is just the Pythagorean theorem, right? So if I want to find the distance between 2 points, right, first I'm going to find the x distance and then the y distance, and then the hypotenuse between that is just the x distance squared plus the y distance squared, and then the square root of that. Next thing is solution sets. So really what this means is that if you have, like it says, y is greater than a certain function, so y is greater than the square root of x, right? What that would mean is, let's look at this graph right here, because this is the square root of x. then if y is greater than the square root of x, that means all this region above the graph is going to be shaded. If y is less than the square root of x, that means all the places below the graph are going to be shaded. And now as for some parent functions, these are some common ones that you should know. So here is x cubed. This is the general exponential parent function. Here I used e to the x, but it could really be any constant. Here is the general logarithmic parent function. Here I used ln x. And then here I have sine x, and then here I have cos x. And the way you differentiate between which one is which is that if you look at at 0, x is 0, sine is going to be equal to 0 at the angle 0, while cos is going to be 1. So this is how you know this is cos and this is sine. Finally, here is the square root of x, and one way you can identify is that at the x value of 4, y is equal to 2, and at x is 1, y is 1. Next up is pre-cal. Now, I know for a lot of us that pre-cal is quite a difficult subject, and so to help you guys out, we here at Simply EDU wrote this. Simply EDU's Premier Prep for AP Pre-Calculus. It's a prep book for AP Pre-Cal. It includes 2 practice tests, content explanations over the entire course, and even a Unit 4 test. Now, Unit 4 is not on the AP exam, but it includes some concepts that are going to be used in future math. As someone who's in Calc PC, I can say right now that vectors and parametrics are definitely going to be used later on. And as you can see on this slide right here, vectors are also, of course, used in the ACT. So I highly recommend that you all purchase it. The link will be in the description of this video. Now, back to the actual pre-cal. The first topic is vectors. Now, as I think we've all heard, a vector is something with direction and magnitude. So over here in this picture, we have vector u, and it's going, well, that way, right? Now, it has, the direction, of course, is, as I just said, that way. And the magnitude is like the length of the vector. Now, the way that you would find the length of this vector is the same thing as you would do in the distance formula. You use the Pythagorean theorem. So, assuming that this A is your start point and B is your end point, you go 3 distances, 3 horizontal distance, and then up 2 as your vertical distance. And so you would use the Pythagorean theorem to get the square root of 13 as your magnitude. Now, on the ACT, they like to use the I and J convention, meaning that they count your horizontal distance, or the x direction distance, as I, and then the vertical distance as J. So if we're saying that U has a horizontal distance of 3, then that would be 3I, and if it has a vertical distance of 2, then that'd be 2J. So the vector U would be defined as 3I plus 2J. Similarly, B would be 2I minus J. So when you're adding vectors, it really helps to just look at this I and J concept. So let's say I want to add vectors U and V. So U, as we said earlier, is 3I plus 2J, and V is going to be 2I minus J because it's going down 1. If I add these together, and then 3I plus 2I is going to be 5I, and then 2J minus J is going to be just 1J. So the sum vector is going to be 5I plus J. And so that's what this vector W is. W is the sum because we're going across 5 and then up 1. And it really helps to look at this like visually because it shows that you're going up this way and then you're going down. And the sum is just going to be how you get from that point A to the final point C. And now unit vectors is just the total vector divided by the magnitude. So let's say I'm looking at this vector U here, right? The magnitude is going to be the square root of 3 squared plus 2 squared, so square root of 13. So the unit vectors for U is going to be 3 over the square root of 13I plus 2 over the square root of 13J. Because what I did is I just got the I and J parts and then I divided it by the magnitude. And so what does that do? That gives me, I guess, a unit of that still is the same direction as U but a much smaller magnitude. Now, next up we have matrices. So that is what you see with all these different pictures here. And so first we have matrix addition, and really this is pretty simple. You just add the values, right? So let's say I added A and B. I would just add 2 to 3, which gets me 5, and then 6 to 3 to get me 9, 3 to 4 to get me 7, and then 5 to 4 to get me 9. So if I'm adding 2 vectors that are like, when you add them, they have to be the same shape, right? They have to be 2 by 2. When I'm adding them, you just add the ones that are in the same spot together. And if I'm subtracting them, it's really the same concept, right? So 2 minus 3 is negative 1, 6 minus 3 is 3, 3 minus 4 is negative 1, and then 5 minus 4 is positive 1. So A minus B is D, A plus B is E. Next up, we have matrix multiplication, and this is a lot more complicated, but the way it works is that So let's say I'm trying to multiply A and B, right? So it's a 2 by 2 vector times a 2 by 2 vector, so the final vector is going to be 2 by 2. So what you're going to do is, to find the top left spot of this product vector, it's going to be the first row of A, it's going to be the dot product of the first row of A times the first column of B. That means I'm going to do 2 times 3 plus 6 times 4. So that's 6 plus 24, that's 30. So the top left column, the top left spot, is going to be 30. Then I'm going to do, for the top right spot, I'm going to do, again, the top row of A times the right column of B. So again, 2 times 3 plus 6 times 4 is 30. So that's going to be 30 is going to be the top right spot of the product. Then for the bottom left spot, I'm going to do the second row of A times the first column of B. So 3 times 3 plus 5 times 4 is 9 plus 20, that's 29. And then the same thing, bottom row times right column for the bottom right spot of C. So A times B is C. Finally is the determinant, and the determinant of a matrix is the same thing as the absolute value. And for a 2 by, and you only need to know for this, you only need to know determinants of 2 by 2 matrices for the ACT, and the formula for that is just AD minus BC. What I mean by that is, if I call the spots top left is A, then top right is B, bottom left is C, bottom right is D, then the determinant of the matrix is going to be AD minus BC. So for A, right, 2 times 5 is 10, 6 times 3 is 18, 10 minus 18 is negative 8, so the determinant of A is going to be negative 8. If I could do the same thing for B, 3 times 4 is 12, minus 3 times 4 is 12, 12 minus 12 is 0. Now, finally, we have some more pre-calc concepts. This time we're going to go into trig. So these are all just some properties that you have to know. So first I have the law of sines. In this triangle, I have side length A, which is opposite angle A, side length C, opposite angle C, and side length B, opposite angle B. So the sine of angle A, over the side length of over sine of angle B over the side length B, and the side of angle C over the side length C are all equivalent fractions. So this helps when you're trying to find an unknown angle or unknown side length. Next is the law of cosines. So if you have two sides and then angle in between and you want to find the third side, or you have all three sides and you're trying to find the angle in between, one thing you can use is the law of cosines to find it. So let's say I'm going to do it for the triangle here. If I want to find what C is, and I have A, B, and angle C, what I'm going to do is A squared plus B squared minus 2 times the side length A times the side length B times the cosine of angle C to find C squared. And if this looks familiar, it's because it's just like the Pythagorean theorem. The thing with the Pythagorean theorem is that, if you'll notice, it tries to find the hypotenuse, right? However, whenever you're doing the hypotenuse, what's the angle opposite the hypotenuse? The 90-degree angle. And what's cosine 90? 0. So in the Pythagorean theorem, they just eliminated this term altogether because cosine of 90 is just 0. That's why A squared plus B squared is C squared. Next, you have these angle sum identities for sine, cosine, and tangent. And so if I wanted to find, for example, sine of 105, right? Then I could do the property here. Set A is equal to 60, B is equal to 45, and then I could use the property to find what the sine of 105 would be. Now again, you do have your calculator with you most of the time, so you don't always need to really use these identities, right? Try your best to use your calculator to avoid having to use these things because there's a lot of room for error when you're using these identities. Finally, we have probability and statistics. And for this is especially where I have to emphasize to use your calculator. So let's say I have a question that's asking about some student ACT scores. So let's just go make up a data set real quick. What I'm going to do is I'm going to go into stat, edit, right? And now I have all these lists in my calculator. So let's make up some standard, like some random ACT scores. So let's go like 36, 35, 34, 33, 32, 31, 30. So I've input all these different values into my calculator right there. Now, if the question asks me to find the mean, median, mode, standard deviation, the sum of all the terms, whatever, here's what you do. You hit stat, calc, one variable stats, right? And then you select list 1 because that's where you input the data. Then you go down to calculate and you hit enter. Now, here it shows all these different values that you can look at. This top one, x with the bar over it, that's the mean. This sigma x, that's the sum of all the terms. This right here is the sum of the squares of all the terms. Then this Sx is the sample standard deviation, while this other sigma x is the population standard deviation. The difference between that is that if the data given is the overall population that you're analyzing, then you'd use the population. While if it's just a sample of the overall data that you're given, then you use the sample. What I mean by that is if we're looking at the student ACT scores, and I'm using this data to analyze all the ACT scores in the world, then these 7 scores that I wrote down is going to be a sample. As a result, I would use the sample standard deviation, which is Sx. However, if I'm just trying to analyze these ACT scores, then I would use the population standard deviation. Now, you don't really need to worry too much about this because I'm pretty sure the ACT doesn't really require you to differentiate, but just keep that in mind in case they do. As we go down, you have n, which is the number of terms. Then you have min x, which is the minimum term. Then you have q1, which is the first quartile, and below that you have the median. Then you have q3, which is 35. So if I do q3 minus q1, that gives me the interquartile range, which is going to be 4 in this case. After that, I have the maximum x value, and that's it. So notice, just from that, what did I get? I got the median, and I got the mean, I got the standard deviation in 2 ways. I got the number of terms, I got the sum, and I even got the sum of the squares of the terms. And notice, I didn't have to do any math. I didn't have to, manually add all the terms together and divide. I didn't have to do any of that. So this is why it's very important to just use your calculator, because it can help you out so much with these stats questions. So next up we have z-score. Now this is a concept that they don't often ask, and usually they're going to give you the formula if they do, but regardless, I'm going to talk about what it is. It really just is how many standard deviations you are away from the mean. So the formula is going to be the term minus the mean divided by the standard deviation. So let's assume that the data value, that the data set I just gave was the population. So, and let's look at the term 31, the score of 31. What is its z-score? So 31 minus the mean of 33 is going to be negative 2. Then negative 2 divided by the standard deviation, the population standard deviation of 2, is going to be 1. Thus, the z-score of that value, 31, is going to be negative 1. Finally, we have tree diagrams. So this is just a way to visualize different outcomes to understand the probability better. So here I have this diagram that I got online that shows the different probabilities of when you flip 2 coins, right? So here we have a 0.5 probability of getting heads, and then a 0.5 probability again of getting heads twice. So the way that you would actually do this is that you would get, let's say I have 100 samples, 100 times that I'm going to coin flip twice. What I would do is I'd write 100 here, and then if it's a 0.5 probability, that means I have 50 times I'm going to get the heads here. And then a 0.5 probability again means I'm going to get 25 double heads. So thus, the probability of me getting heads twice is going to be 25 divided by the initial, so 100. Thus, 25 over 100 is 0.25, or 25% chance. So that's going to be it for this video. Please stay tuned for part 2, in which I do a live walkthrough of an ACT math section.